Welcome to section 2.1, day 3, one-sided derivatives and graphing f prime. Objective today is to graph derivatives and calculate one-sided derivatives. So here we're going to start with graphing f prime. F prime is a function, so we can graph it just like we would graph f, the function f. We still put x values on the x-axis, but we put y prime, the slope values, on the vertical axes. So here we have a piecewise function, and we want to graph it. So we want to graph f prime off of this function f. So the first thing to remember is this is our y prime axis. This is my x-axis. This is going to be a little hard to do for some of this. So what we do is we're looking at the slopes of our graph, and that's what we were going to graph on our f prime graph, is the slopes. So when we look at this first part, we have from -5 to 4, we are going down 4 units over 1. So we have a slope of -4 coming in at -5. So we are at -4. We're coming in all the way to -4, and that's our end point. So that is the slope of -4 coming in. Oh, I went too far. So from the beginning of our graph, has a closed circle, to x is -4, we have a slope of -4. So that is how we graph the first piece. We are then going to do the next piece. So we have a slope going from -4 to -3. We are going up 1 over 1. So we have a slope of +1. So we are going to graph that above the x-axis. And it's going to go from 0. And that is my slope of 1. Notice I have open circles, because at the point, we do not actually have a slope of 1 where it meets up. From -3 to +2, we are going to go down 2.5 and over 5. So we have a slope of -1/2. So our slope here is -1/2. Let me see if I can get it bigger. So at -1/2, this is going to be hard to show. And it goes all the way to 2. And this is connected. Again, those are open circles. And then we have a slope going from -2 to 3. We're going up 1.5 over 1. So we have a slope of 1.5 positive. So that's going to be above at 1.5. We use, let's see here what we haven't used yet. So here we go, 1.5. Open circles, connected. And then the last piece is we are going down, and we have a slope of -2.5, going from 3 to 5. So -2.5 is right here. And we're going to 5. And that is this is a closed circle because it's the end of our graph right there. So that is the graph of f prime. What we are doing when we graph f prime is we are basically graphing the slopes. So we have a positive slope, it's above the x-axis. If it's a negative slope, it's below the x-axis. As you notice, the endpoints have closed circles, but everything in the middle has open circles. So one thing to keep in mind with f prime, when we're finding these derivatives, we are finding slopes. And so when we graph f prime, we are just graphing all the slopes as we go along the graph. It says graphing f prime from f. So when you're graphing f prime, we always want to look for a couple of different things. For which values does f prime of x equal 0? For which x values is f prime of x the slope of f? When is it positive? For which values is the slope going to be negative? So here we have a cubed function, and we want to graph f prime from f. So we're going to take and graph f prime of x over here from our f of x graph. Now this is my y prime. This is my x. So we want to look at this. It says, for which values does f prime of x equal 0? When is the slope of our graph on the left equal to 0? It happens twice. Happens at x equals 0. And again, it happens at x equals 2. We know our slopes are 0 at those 2 points, so we mark those on our f prime graph. We know it's going to cross, our slope will be 0 at 0 and 2. Let me use a different color. So at 0 and 2. We know that's where our slopes are 0. Then it says, when is our slopes positive? When are we positive? Well, our slopes are positive when we're going between 0 and 2. So 0 less than x less than 2, we are positive. And we are negative coming in from the left. So x less than 0. And again, x greater than 2. Well, we use this information to figure out how to graph this. We don't necessarily need to know the exact slopes in these areas. We just need to know how to put this together. Well, we know we're going to be above the x-axis between 0 and 2, so we know that we're going to have it like this. We also know we're negative before we get to 0, so we're down this way. We know we're 0 or negative after we get past 2, so down this way. This is a sketch of the graph. We have a negative slope coming into 0. Then we have a positive slope going from 0 to 2, so we're above the x-axis. And then we have a slope of negative going out to the right, past x is greater than 2. This is a sketch of the graph. Okay? And this is what we do when we are graphing from a f function, f of x function, to an f prime. We look, where do we cross the x-axis? Where are the slopes 0? Then we look at where our slopes are positive and where are negative, and we can use those to sketch a graph of f prime. So here we have another one. It says graphing f from f prime. Sketch the graph of a continuous function f with f of 0 equal to 2. So we know that f of 0 goes to 2, and we know that f prime of x has a slope of 2 when x is less than 1, has a slope of negative 2 when x is greater than 1. So here's my y. So we know that f of 0 goes to 2. This is my f of x graph. So we know that we have 0 goes to 2. That's given. When we are x less than 1, we have a slope of 2. So when x is less than 1, our slope is a positive 2. So we know we're going to be going through here. That's a positive slope of 2. And then when we get greater than negative, or when we get greater than 1, we have a slope of negative 2. So that goes through here. That's a very crude graph, but we have a slope of negative 2 going out on the right. And that is our f of x graph given our f prime of x. And a place to start with f of 0 equal to 2. And this is how we go back from an f prime graph or from f of prime to graph f of x. Here it says find the left and right hand derivatives at x equals 0. So we're given f of x equals 1 minus x squared when x is less than or equal to 0, and 3x plus 1 when x is greater than 0. So we want to find f prime of x. And it equals a limit. This is our definition of a limit, or a definition of a derivative. And we have 1 minus x plus h squared minus 1 minus x squared over h. This is equal to the limit as h approaches 0 of, when we expand it out, we get 1 minus x squared minus 2xh's minus h squared minus 1 plus x squared all over h. This is equal to the limit as h approaches 0. When we go back through, our 1 and our negative 1 cancel, negative x squared and x squared cancel. We can pull out an h, and we're left with negative 2x minus h all over h, which becomes the limit as h approaches 0 of negative 2x minus h. We can now plug in 0 for h without causing problems, and we get negative 2x minus 0. So this is negative 2x. So f prime of x equals negative 2x. When we want to check it for 0, f prime of 0 equals negative 2 times 0, which is 0. So that is our left hand. That's our less than or equal to 0. And then we do the right hand. We're going to do the other function, f prime of x. We have 3x plus 1. So we can use the limit as h approaches 0. We have 3x plus h plus 1 minus 3x plus 1 all over h. And this equals the limit as h approaches 0, 3x plus 3h plus 1 minus 3x minus 1 all over h. And then we can simplify some things out. We can cancel out the 3x and negative 3x, the 1 and the negative 1, and we get f prime of x equals, we have f prime of x equals the limit as h approaches 0 of 3h over h. Simplify that, and we get the limit as h approaches 0 of 3, which is just 3. Left-hand derivative is 0, and our right-hand derivative is 3. And the two derivatives don't match, so we cannot find a derivative actually at 0 on this problem because the left and right-hand derivatives do not match. That's how we do left-hand and right-hand derivatives with a piecewise function. Do each one separately, and you'll notice that when these meet, we have two different slopes coming in from the left and right, which sort of makes sense when you look at this, that the slope of the line, 3x plus 1, is the slope of 3, and we get 3 for our derivative. And then when you look at 1 minus x squared, at 0, the vertex is at 0, 1, and you'll notice that we have a slope of 0 because that's where the horizontal tangent, we have a slope of 0 at the bottom, or at the top of at the vertex, and these two do not match. So we would not have an overall derivative at x equals 0. We can find the left and the right derivatives, however. That was section 2.1, day 3, one-sided derivatives and graphing f prime. So today we did some one-sided derivatives there at the end. We also graphed f prime off of f of x, and then we graphed f of x off of f prime. That is what you'll be doing today. Thank you for watching, and have a nice day.